Hi guys, this is Gordon LaPlante from gCreate, and this is part 2 from our Slicer series where we're showing you how to install and use Slicer for the Gmax printer. If you've watched the previous video, we showed you how to download and install Slicer as well as the Gmax configuration files, and we did a brief overview of basically all the Slicer functions and what they mean. Now in this second video, we're actually going to slice something. If you haven't watched the first one, we highly recommend it because it's really good to have a general overview of the program you're using and what settings you're going to change before really jumping into slicing. And we know you want to slice, but again, it's your choice, and we hope you find this useful. So basically, here is Slicer 1.1.7, and you can find on our website we're going to have a gCreate tutorial Slicer folder or download section where you can download the files that we're using and work right along with us. So go ahead and open up Slicer, which I happen to have open here, and you'll notice that immediately, if you follow the previous one, the previous video, you'll see that you have the print settings, filament, and printer settings that we've suggested. Um, I do want to add that from the previous video, if you go to File, Preferences, and set your mode to Expert, that's actually where you'll see these drop-downs. Otherwise, these drop-downs won't appear. So make sure you have that setting turned on, or else you can't slice along with us. So now go ahead and go to our website and download these files here. And the first one we're going to use is called Candle Holder 1. This is kind of a funny story that for Valentine's Day, I was actually I was cooking a nice dinner, and I realized that for the candles I purchased, I didn't have any candlestick holders. So I quickly jumped on the computer, designed these candlestick holders, and printed them while I was cooking. So at least we had something to hold these candles. So it's actually pretty funny, but it worked out well. And it's a very good, simple model because there's not a lot of complex shapes in them, but it's a great one to experiment with. So to get started with Slicer, as you see here, it says drag objects here. So what we're going to do is go ahead and drag candlestick holder 1 right into your slicer. And what you should see is your model appear. A few things you should note is under info, it shows you the size of the model in millimeters, the volume of the model, how many facets it has, and if it's manifold. This manifold one basically means if there's issues in the model, that it's not like a watertight closed model, you'll see this show up with a bunch of issues here, and Slicer will actually try to repair them. In most cases, it works pretty well. Sometimes, if your model's really screwed up, this will have a lot of problems. One good way to see it is basically to, in Slicer 1.1.7 at least, to double-click the model, and then you'll have a 3D representation of the model pop up. And this is where you can see if there's any open faces or any problems. This particular model has no problems. You'll see that it's a very clean, simple model, and it's a candlestick holder. So I just wanted to show you that if you see under manifold there's errors, it's a good indication of something's wrong with your model. Oh, actually, so again, if you double-click the model, this is a good way to visualize your model, and also I can briefly describe basically how the slicer is going to operate. So what we're going to do is we're going to slice this model into a series of layers. This particular model, it doesn't require support, and it doesn't require a whole lot of infill. By support, what I mean is this is obviously the side view of the model here, and you'll notice that this overhang here, it's not too extreme so that our printer can actually print this type of overhang just fine. If this was a much steeper overhang, something like this, then you might have to have support below to actually hold up as each layer is printing. But in this first model, we're not going to go ahead and we're not going to have any support required. We just want to show you a very simple model to slice with. Again, these settings here are built into Slicer. If you wanted to cut the model and have a flat surface in the bottom, or split the model in half, you can do that, but we're not touching these. These are ones you can play with on your own if you choose. Okay, so basically what we want to do is we have our model loaded. If you wanted to go ahead and obviously view the info of the model is here. The different settings for the different material types and the different print settings you might want to use are here. These are the default settings that we supply with our printer. And you can choose your default material. As you build up your material and your filament collection and your print setting collection, you can add your own presets if you want. Okay, There's a few different buttons here that we're not really going to play with right now, but the basics are that if you want to, let's say, print more than one of these models, there's a button here where you can actually duplicate and print many of these at one time. So every time you click plus, it's just going to add one of those models, which you can actually individually move around on your platter if you wanted to. And as you subtract, it's just going to take away the last one that you added. This is a good way that if you want to print 10 of the same object, you can do so. Also, if you want to subtract the model or rotate it, you can do that. Scaling is very important. We've noticed that with some of our models, the conversion from inches to millimeters or vice versa, scaling is very important. So if you pull your model in and it's very small, chances are you have to scale it between millimeters and inches. If it's very small and you want to go to the proper size, we found that the proper scale is actually 2450. That's the proper scale to go from millimeters to inches, or vice versa. But in this particular case, this model's already been scaled and everything's proper on it, or actually it was exported with the proper scale. You can also split and cut view/cut your model. View cut your models is the actual double clicking, as you see here, or you can also click that. There's also different settings you can change per your model. There's a lot of modifiers you can add and a lot of more advanced features. We hope to cover that in a future video, but for now it's definitely not important. So basically, after showing you the general overview of the main window, now that you have your model loaded, if you go to Print Settings and you make sure that you have medium quality selected, you can pretty much go ahead and slice your model. What we're going to do, I want to show you, we're going to slice it in 2 different layer heights so you can see the dramatic differences. So when you click these different settings, what you can do is actually change these settings and then save it as a new preset if you'd like. Or you can just go ahead and do a one-off and go ahead and export it as is. But basically, these settings here are supposed to be jumping points. They're not supposed to be end-all, solve-all settings. But again, as I mentioned, I want to do 2 different slices. So one will be where layer height's at 0.3, and we're going to set infill, keep it at maybe like 20%. Speed, everything else should be fine. And then go back to your platter, and now we can go ahead and export G-code. Let's just go ahead and save it. I like to save it so that I remember what the layer height was. You can actually open the file itself, but it's easy just to see the file name. So let's say it's, what did I say, 300 micron is the actual layer height. And the slicing of this should be relatively quick. It's not a very complicated model. As you see, this is real time. It was done in a matter of seconds. Now also what we're going to do is go ahead and turn the layer height down to 0.1. So we went from a 300 micron layer height to a 100 micron. So it's actually 3 times as many layers, or I guess 1/3 the layer height. So theoretically, this should take 3 times as long to print, but yet our print should be much smoother. Lowering the layer height and making it a finer resolution, it really only comes into play, in my opinion, when you get very low slope surfaces. So you have to remember that when you're slicing this model, it's slicing the side view into many layers. So when it's slicing these into a lot of layers, this area up here, it actually, because the walls are almost vertical, you don't notice the layers as much. Now down here, because it's so flat, think of it as like a topographic map. You'll see the actual layers on this lower portion here. There's advanced techniques where you can actually set it so that this lower part here will actually have finer layer height, or a finer layer height than the upper part. But for now, I just want to show you where we do 2 completely different models, or different slices, one at 300 micron and one at 100 microns. So now that we've already set this layer height to 100, there's no other changes. Everything else is identical. Let's just go ahead and go to Platter and do Export G-code now. You'll see that the first one's already been saved, called Candle Holder 300 micron. Let's go ahead and save it as 100 micron for the new file name. And again, it should slice pretty quick, but it's going to be much slower than the last one because, well, it's actually pretty quick because now we have 3 times as many layers. Okay, now if we open up this folder, we should see one file and another file. You'll notice that the 100 micron is 2.1 megs, and then the 300 micron is 849K. So it's actually a pretty big difference between the 300 micron file and the 100 micron file, because this 100 micron file has so many more layers. So keep that in mind. Quality is not always what you want. Sometimes you want to do a quicker model because you don't have 3 days to sit there while it's printing, but yet it's very important per model, because if you have your model has a lot of low flat surfaces, well, maybe you do want to do a higher layer count. Okay, so now that we have those two saved, I'm going to go ahead and go over and print them, and I'll show you the results. Hi guys. So I loaded the 100 micron file into the printer, and it's printing away right now. If you listen softly, you might be able to hear it. It's actually behind me, but basically, while that's printing, I want to give you guys a quick overview of now that you've sliced your model, how can you actually see what it looks like sliced-wise? Like, how can I actually watch those paths? We're printing our model from the LCD screen on the printer, so we're actually not controlling it with the computer. But basically, if you want to see what every slice looks like, which I highly recommend, you can use Print Run or Pronterface to do so. So I actually have it open here. We're not going to go into what this program is in this tutorial, but basically this is the recommended program we use, or we recommend anyway, as the host software if you want to run your printer from your computer. But the reason I bring it up is because it also has a visualization engine to visualize the G-code file that you just created. And there's plenty of them out there. Repetier has one and everyone else, but this one's the quickest, in my opinion. It just works really quick and it's easy. So go ahead and open it, and now you can go to File, Open, and open the G-code file that you just created, either one, let's say at 100 micron. And now if you give it a second, what it's going to tell you is some important information. So first off, how much filament is used in the print. So we're using about 4600 millimeters. In my honest opinion, that's a pretty small model. Each 0.75 kilogram spool from ColorFab has about 250,000 millimeters of filament. That's a pretty good guess right there. So that would mean that each 1 kilogram spool from eBay or whatever would have maybe about 320 or 310,000 millimeters. So we're only using 4600. So it's a pretty small print. You also can see the overall width, the depth, and the height, as well as the estimated duration. So this is saying it's going to take about 55 minutes to print this model. Don't forget, this is at 100 microns, so it's a very fine layer height to print this for about an hour. I found that the estimated duration of 55 minutes, it seems like pretty much across the board, add 10% to that time, and that's your actual time. If you're doing a 20-hour print, add at least 2 hours or an hour and a half, because sometimes the newer version works much better, but I don't know, it's still a little bit off. So this might take, instead of 55 minutes, it might take more like 60 minutes, something like that. But yeah, this is a very useful tool because you can see how much filament you're using and the estimated time. Now, if I go ahead and open the 300 micron file, you'll see that the amount of filament actually went up, but the time cut pretty much in half. As I mentioned in the earlier portion of the tutorial, you would estimate that because there's 3 times as many layers for the first one, it should take 3 times as long. Well, that's not always the case, but sometimes it is. So in this particular print, even though we made the layer height 3 times as fine, it's actually only twice as long to print it. So, you really have to make a judgment at that point. Do I have an hour to wait, or do I have... In the case of the candlestick holder, I had to print this in time for us to eat, so I had to do a much cruder layer height. But if you have all the time in the world, well, maybe 1 hour is not the worst thing, or maybe 5 hours is not the worst thing. So really keep in mind, your quality versus your time. Yeah, using these G-code visualization tools is a great way to test all the different slices you might do, because you can slice this 20 different ways and then see what each one does. Something else that PrintRun has is if you double-click the actual center space, you'll get a quick visualization of the model. So if I zoom in on here, right now I'm on the top layer. As I scroll down, in cyan there, you can see what every single layer will look like. So this is a very useful tool because you can see that, let's say about midway through the model, here you can kind of see the outside. This is the shells I was talking about. And then here, these diagonals, this is the infill. And then as I go down one layer, the infill goes the opposite way. So the way this particular infill works is each layer alternates, but it still makes a grid. And you'll see the actual outside shell is stepping in, because the portion of the model that we're at, as you turn it, here you can see all the layers on a side view basically. As we step up, that's each one of those layers. And then here's the infill, because this happens to be a solid portion of the model. This is a really good way to think of 3D printing. Don't forget that there's a series of layers. So as you're going up or down your model, you can see all of those layers. This is very important because at this point in the model, if our model went way out here, well, there's nothing below to support it. It's not printing on top of anything. Because this angle is not too steep, it's actually printing on top of itself from below. It's just enough that it's close. But if it was really extended or way out here, well, that's where you would have to have the support material that we were talking about. Otherwise, as it prints that layer, it'll just drop on top of nothing, and it just creates a mess. So keep that in mind while you're slicing. But in this particular model, even at 300 micron, we shouldn't really need it. So actually, I want to go ahead and open the 100 micron one again, because you can see that there's a lot more layers. Okay. Now you can see, look at how thick all that is. Now as I scroll, and this bar here, actually, these are all the layers. There's a lot more layers. Now the important thing is, as the layers get finer, as I zoom in, you can see that overhang doesn't matter as much, because now each layer going up the next step, it's just a smaller overhang. Whereas before, each overhang was very big, very big, very big. And you can also see, let me scroll over here, as I go down the layers and we get towards the bottom, as I mentioned, now here's where you start to see that kind of topographic map I was talking about. Because it's such a shallow angle, as it's printing in the center part of the model, it's actually printing these outer layers as well. And then look, it's actually doing 4 outer layers here, and that's the last one. And then it's doing, what is it, like 8 almost? Yeah, 8 layers here, and then a whole bunch more. So very shallow portions of your model is where you'll actually see the layers the most. Now, in the case of that 300 micron file, this is going to be much, much more of a rough portion of the model. You'll actually see the layers go around and around. But again, if you're going to finish it with a paint or some sort of some finisher, Bondo or something, it doesn't really matter. But if you're going to just print your model and pull it off, well, maybe you want it finer. But it really is all a matter of time and quality that you have. But yeah, that's basically, I just want to give you guys a quick overview while we wait for the print to finish of how to actually look at your model and see how much filament you're using, as well as how long it might take. So I'll get back to you in a second. Okay, so the print's just finished, and I just popped off the 300 micron print, which you can see on the left side of the screen here, and obviously the right side of the screen would be the 100 micron print. And you could actually see a pretty stark difference between these two prints. The filament I chose to use is actually a color fab. I believe it was shining or sterling silver. It's actually a PLA, but it has a very high kind of reflectivity, kind of specular quality to it. So it's a little difficult to print with, depending on if you have your print settings or your slicer settings set up just right. But I purposely chose it for this tutorial so you can actually see the stark differences between the two. Also, I know earlier in the tutorial we kind of estimated how long we thought it would take to print each model. So it turns out the 300 micron print on the left side took about 38 minutes, while the 100 micron print, which has essentially 3 times as many layers, took about 1 hour and 9 minutes. So it was a little over twice as long. Sometimes it takes 3 times as long, sometimes it's not quite that dramatic. But in this example, as you can see, maybe it's worth that extra, twice as long time to get the results you see. So let's go ahead and jump right in. For the 300 micron print, as I mentioned earlier in the tutorial, the upper portion really didn't have a problem. It printed pretty nice and pretty clean. You can kind of see because you're kind of going up along the layers, you really don't notice the layers as much compared to the lower portion. So the lower portion, because it's such a low slope right here, you really notice the layers, and you really see the steps between layers as well as the infill from the printer itself. So comparing that to the 100 micron print, it's a dramatic change and a dramatic difference. So in this particular example, even though the top might not be all that much more detailed, you really obviously notice it in the lower portion. So it really depends on what your model qualities are and what model you're bringing in, and that's what's going to determine your slicer settings. If you happen to have a portion of your model that looks like this, well, maybe you want to do a finer layer height, somewhere around 100 microns or less. But if your whole model consists of a tall vertical piece, well, maybe you don't need to go that fine of a layer height, and you can save yourself some time. Also, what I want to bring up, as you see pretty much right here, this is the aligned seam I was talking about. So we had aligned seam turned on, or the seam itself was set to aligned. So you actually see this is the point where the printer runs around and then lifts up, and then runs around and lifts up. So it lifts up in the same spot each time, basically creating a seam. Depending on what your print is, you might be able to just turn it and hide the seam so you don't care. But if we turned on the seam to random, this individual seam would be spotted all around the model, so you might not really notice it as much. In this example, you can also see on the inside here. In this example, it didn't really bother me just to have a seam there. So yeah, that's why we kept it on aligned. Also, I want to bring back that if you did choose to print at the 300 micron level, and you have this pretty ugly lower portion, if you're going to finish the model later with another material, well, maybe it doesn't matter. So maybe you save yourself some time by just going ahead and lowering the layer height, or I guess raising it, and making it much more crude to get quicker results. So okay, so here you go. You can see some actual first physical results from your very first slice. So as you just saw, we just finished the first print of our first model, the candlestick holders, which was, it was actually a pretty simple, relatively simple model on purpose so that you can kind of get your feet wet with actually printing. What we're going to do in the second half of the tutorial is actually slice something that has a few more variables and a few more areas that you can see what 3D printing is really about. Instead of just printing very simple models, sometimes you're going to have more complex shapes, or you're going to need overhangs or bridges or support material. So we went ahead and created what we're calling the gCreate calibration cube. So it's kind of a cube that actually can nest together with other cubes, and it has pretty much a lot of different things in it that will relate to all the different settings for 3D printing. So I'm going to go ahead and open up 3D Studio Max, where we actually designed the calibration cube. And you can see here, this is the cube itself. So basically, as I kind of pan around, it's a 2-inch cube that has chamfered edges. And there's an opening on one side that has these two little, kind of see here, these two little nubs. This corresponds with the opening on the other side. And there's actually openings here. So if I were to take a second cube and put it over here, you can just literally snap it in place. It actually rotates. You have to rotate it and then snap it in place to get it to stay. Or you can also add cubes above. And then this upper portion here actually seats into the model. You can kind of see in wireframe here. It actually goes inside the model on the bottom. So if you look at the bottom of the model, there's actually a hole there. So deleting these guys, I'm going to delete these other ones. You'll see that, as I said before, going around the model, these two pieces on the side here are cylinders, and these are two domes or spheres that actually correspond to these holes on the other side. So this whole model really should kind of connect together. And there's a lot of different things in this model that's great for 3D printing, whereas below this piece here is essentially printing on top of nothing, so we have to support it with support material. Same with these guys here. This is actually what's called a bridge. You're bridging straight lines from one side to the other, but we're actually going to go ahead and turn support material on for those as well, just to show you it. These projections here, as you print layer by layer by layer, it gets to this point and there's nothing to print on. You can kind of see the side view here. So that these pieces here will just droop into nothingness, so we actually have to support those as well. Inside here, these circles, these kind of cutouts, actually the top here could probably be printed without support, but it sometimes gets challenging because as it's printing layer by layer and working its way up, these edges really start to kind of bend sometimes and tend to have some issues because there's really nothing it's printing on. So anyway, so we hope if you go to our website, just like before, and download the files, you'll see this calibration cube, and you can go ahead and print it along with us. So let's go ahead and close this, and now we're going to open Slicer, just like before. I have it set right now. I'm just going to keep it as a default to start with, is medium quality. We're going to use ColorFab PLA, the black PLA, and we're going to do it with a 0.5 millimeter nozzle. You could do this with a 0.35. You just have to select the obviously the different nozzle size. So just like before, with Slicer open, go ahead and open up your folder, and under gCreate Calibration Cube, you should see the STL file. So let's go ahead and pull that in here. And also, just like before, you'll see that manifold is set to yes. That means it's basically a watertight, nice, clean model, which we made in 3D Studio Max. Here's your size. So it's 54 millimeters by 57. 50 millimeters, somewhere around there, is actually 2 inches. So it's 2 inches by 2 inches, and then it's actually a little taller because that center part pops up, as you can see here. So this was that preview that you could double click on and get the preview. So the settings we're going to use for this calibration cube are pretty simple. We're going to do one print at 100% scale and keep everything just one simple cube. If you go to print settings and you already have it set to medium quality, you should see the default layer height is 0.23 millimeters, or that's 230 microns. So we're actually going to set it to 200 microns, or just 0.2. It's a really good, that's a great layer height. You'll still get a nice smooth finish on the outside, but if you go lower than that, you don't necessarily need it because the edges of the actual cube are vertical, so you won't necessarily notice the difference. Otherwise, you'll just waste some time. If you look at vertical shells, we're going to keep it at 2 for now. I'm looking at the settings here. We're going to keep it at 2. Horizontal shells for both the top and bottom solid layers, there's no need to change that. Really, the only thing we're going to change would be the actual infill. By default, we set it to around 40%, which is a fairly solid infill. Obviously, 50% would be half full. We don't really need this to be a solid infill, so if we lower that number, it'll just speed up our print. So if we're going to go down to actually 15% and keep it as a pretty light infill, which will speed up the print a little bit, but also we don't need that extra support. Everything else you can leave the same, just as I mentioned in the earlier portion of the tutorial. Mouse over all of these different settings and you'll get really detailed tooltips that tell you exactly what it does. Okay, going along. Let me check a look. Speed. We're not really going to change anything. The only one we might change would be external perimeters. To speed up the print, you can speed this number up and maybe put to 60, 70, or 85 millimeters a second. If you have a lot of detailed, small, little outside movements, a lot of jagged movements, or you're doing a very detailed model, keep this number low because that'll make sure that the outside of the print is nice and clean. But if you're doing basically a sphere, which is a very simple kind of object, or from the earlier portion of the tutorial, if you did the candlestick holder, there's no reason to speed this up because it's just a simple curve. There's no jagged edges. In this case, we'll just leave it at 45. That's our kind of our default value. Now, really, the only thing we're going to change next will be support material. By default, we have support material off because for a lot of our models, any of the models for the actual printer, we don't use support material. But depending on what you're printing, you might have to turn it on. So when you turn on generate support material, what it's going to do is any of the portions of the model that overhang on top of nothing, which I'll show you here, it'll actually add support material. So basically, this portion of the model, which is essentially hanging on top of nothing, and when it gets to that point of the model, it's going to try and print on top of nothing. It'll generate support material right here. Also, the inside of the model, as you can see from the side view, this here is printing on top of nothing. So it'll actually generate support material below that, which then, when it gets to this layer of the model, it'll actually have something to print on top of. So you'll see various portions of the model which will have support material. These projections here on the side will have support material because there's no support below right now. And the way we're turning it on, this here is actually called a bridge because you're bridging. Let me get the side view. You're actually bridging from one side to the other. It's a straight shot. So you can turn on a feature where you don't need support material below, but we're going to leave it on just so you can see what it looks like to have support material there. But our printer can actually print from one side to the other without necessarily needing support material, but you might get a little bit of a sag as the filament goes across. So it depends on if that matters to you or not for that particular model. Go ahead and close this. So back to print settings and then support material. We're going to turn it on and we're going to set it to 20%. So what this tells us is anything that's 20% or less will then generate support material for that portion of the model. So any portion of the model that has an angle or a face that's really 20% or less, it'll generate support. In this particular example, as you can see with the tooltip, 90 degrees is considered a vertical side. So as you start turning that to become horizontal, then you're going down to 0 degrees. This number here, 20 is probably the lowest you might want to go. You can go down to 10 or 15 depending on your model. But basically, if you do need support material, you have to look at your model to see and determine yourself where you need to have it. Everything else, we really don't have to change. We're going to keep output, extruder, advanced. Everything else we're going to keep the same. Make sure you have your filament set to whatever you're using. We recommend, especially if you're starting out with 3D printing, just stick with PLA. We also recommend ColorFab because it happens to just print really well. But PLA is a little bit easier to deal with than ABS, so just stick with PLA at the beginning while you get your feet wet. And then printer settings, that's it. So now that we've loaded our model, we have everything ready to go, we've changed our settings, we can click Export G-Code, and this will actually export our file. So if you want, you can actually, in your file name, put some of your settings so you remember what it was. So I want to say this is 200 micron, and I'll remember that was 200 micron layer height. If you ever change your scale, sometimes what I'll do is say like 50%, and that means it's 50% scale, but it's up to you. I just find that having it in the file name is actually a little bit easier sometimes than having to dig through the actual file to figure out some of your settings. So go ahead and click Save. And now you'll see the actual slicer engine generate perimeters and go through all the calculations to make your G-code. Okay, so the gCreate calibration object just finished printing, and I just popped it off the printer. And as you can see here, I left the support material on so that you can see what it looks like freshly off the printer before removing the support material and cleaning up any problems in the model. So it was printed in ColorFab Black PLA, which it really prints like a great material, and as you can see, the layers look fantastic. And also, as I mentioned, this was set at 200 micron layer height, which happens to work really well for this type of model because we don't have a lot of shallow kind of sloping curves, but rather we have more vertical angles on the sides. So if you look closely at the model, I'm going to kind of do a rotate so you can see what it looks like fresh off of the bed. Here's the support to support the bridge above, and this is supporting the top of the cutout here, the circular cutout. You have the support material on the sides here, supporting these four projecting pieces. On the top here, it's actually interesting to note that you can see the top is a little shinier than just inside, down in here. That's because the top printed a little bit faster because the bottom was printing all these other pieces. So it really depends on the speed that you're printing at will sometimes change the sheen of the actual material. So just something to keep in mind. If you look at the bottom here, you can see the support material holding up the center sphere there. Yeah. And then here's the top and the top of the sphere in there. This was printed on with the 0.5 nozzle as we typically use, and you can see the results from that. The corners themselves have a slight radius, but it does print much easier and better with the 0.5 that we found over the years. Okay, so I'm going to slowly pull apart the support material, and we can see what the model looks like when we're done. So I finished removing all the support material from the model, and I cleaned up a few of the edges that were that had a little bit support material kind of stuck there. I used an X-Acto, and as you can see, the print came out pretty nice. Unfortunately, here, this is my own fault. I got a little too aggressive with the pliers and dug into the edge of the model. So it really pays to take your time removing support material if you really care about your model. But in the end, here you can see what a calibration cube should look like. We had a little support here, obviously, to hold up these little pieces. These actually could be printed without support, but we turned it on just to show you what it would be like to remove it on the sides. And then underneath here as well, this here had some support material. And as we go around, you can kind of see every side. Underneath, there's that hole underneath, so that the camera, so that this top part here can seat into it from if you wanted to place another cube on top. And then obviously these two pieces here and these two pieces, as we mentioned, line up to the other side so you can snap together a cube there. And lastly, this piece here actually will lock to another cube that you rotate to lock it into place with these little pins on either side inside of this part here. So there it is. That's the second print we did with the calibration object, that you can print as many of these as you want and lock them all together and make a bunch of different designs. But we hope you enjoyed this tutorial and you learned something on how to kind of slice different types of models, and we hope you learned that every single model has different settings, or should have different settings anyway, depending on what the model looks like. You know, you're going to have bridges and overhangs, and you might need support material, you might not. You might need a finer layer height, you might not. So it really depends on what your model looks like, and the more you slice and the more you print, you'll just kind of learn this along the way. So we hope you enjoyed it and look forward to part 3, which will give you a whole bunch of new information.